Hi everyone, welcome to that channel and the AI meetup. It's the Artificial Intelligence and Cloud Toronto meetup group. Really great to have you here. We have a really great show for you. My name is Denise. I'm an executive producer here at That Channel Studios. We're one of the first internet studios in Toronto since 2004 and partnered with YouTube. So if anyone is ever interested in doing video production, having a meetup, seminars, we have done feature films here and commercials, so you can really get creative or even host your own show. Very good for business, so definitely keep it in mind. I am very excited to introduce our very first speaker, and his name is Shailendra Pathak, and he is a machine learner and he uses PySpark, so very nice to have him here. And big shout out to also to Hiren and Chandran. And yes, so welcome to the meetup, and I'd like to now introduce Shailendra Pathak. Thank you.
Hello all. So here I am, Shailendra. Just to give some background, I have been doing analytics for like 15 years now across different countries, geographies, domains. Started with the financial sector, did a lot of credit risk and market capitalization and things like that, regulatory analysis as well. Then moved on to telecom, did like 5 years in telecom sector for analytics and like 4G, switch over 5G and things like that. Now also doing retail as well as some kind of brick and mortar thing as well. And over a period of this long career, I would say, I've seen it transition to multiple levels. We started with something called SPSS modeler and things like that, IBM and small software like lightweight software, which moved on to later on to SAS, and which was quite good, which is still industry stalwart as far as credit risk modeling is still considered. And then the open age came, and now we have so many software. It started with R, which was very, very academic and econometric, I would say. By the way, by degree, by education, I'm an econometrician, so it's not that I don't like econometrics, I love it. But the thing is, over time, as computing power as well as the data storage increased, now we have moved on to machine learning. So that's a precursor to everything, because you cannot have machine learning if you have 10,000 rows of data. That's bullshit. Okay, you need tons of data so that you can enable machine learning, right? So today we are talking about Python and PySpark and Spark on the whole, right? These are all just tools. They are just tools for you to be used when you feel they are good enough or they are relevant enough, right? If you have 100 rows of data, it doesn't make sense, right? So very important thing to understand is that you need to have the use case for everything before you jump in it, right? So now let's talk about Spark, given that we have some context. For data scientists, and yeah, again, let me just set a few things right here. We are talking about Spark application for data science. We are not talking about Spark in general, because it's a huge platform. You can literally make anything, as long as it has data in it, right? So we are talking about data science, right? As some of you would know, Spark, you can basically code in Java and in using R also, Python, Scala. So, but if you are a data engineer where your job is mostly just to leverage the data and move it from here and there and create stuff, you are mostly doing data engineering stuff, then you would most likely use Scala, because it's far more wide in terms of its application. But when it comes to data science, when it comes to insight generation, you really start somewhere, and that somewhere is you have some data and you do a lot of data manipulation, data mining, data, you move a lot, you create new things, and then you apply machine learning stuff. Obviously, you cannot run a neural network model in Java. It's not going to make sense, because you are not going to design that program or algorithm by itself, right? So what we are going to do in today's class, we are going to touch base on what PySpark looks like. So Spark, the moment you touch Python API to code in Spark, it's called PySpark, right? If you use Scala, you can do the same, right? You can type in, you can code in Scala, and it will still be on the Spark platform. Some people use R also, it's pretty limited. Of course, you can code in Java. You can use SQL within Spark, which is very, very handy, because like most of us, if you work in the data field, you kind of do and know SQL, right? So let's start. So since we don't have much time, so I'll just uh, quickly give you a glance of what, why do we need Spark? That's the first thing that you should be asking, because there are so many software available and so many different things available. So some of the, it's slightly smaller and the contrast is crazy. But anyways, the most important thing is you would have heard about Hadoop and MapReduce and everything, and it was a wave, but now very few people talk about working in Hadoop, right? People want to move up. Why is it so? Because if you look at Spark, the way it is designed, very, very loosely speaking, you have an HDFS layer, which is nothing but the file management system, which you can use commodity hardware and you can write tons of data by using like cheap stuff, cheap hardware, and you can scale it up. To control that environment, you need something for resource management. That's what is Yarn, and together it is called Hadoop Yarn. The problem with Hadoop is that everything is a read and write cycle. So for every aspect, you have to tell Hadoop that start from here and end there. There's nothing in between. This is solved by the Spark environment, right? In Spark, you have above the Hadoop cluster, you have a high-end server as well. So what it does now, the first instance is, let's say, a read instance where you are just loading up the data from the Hadoop clusters and so on and so forth. But then after that, whatever you do, you kind of hold it in memory, right? That's why Spark is always called as in-memory processing, right? It leads to overflow if it can't process it, right? But then it's stable because it goes back to Hadoop. So it will not crash, it will still do its job, maybe slightly slower. This combination of a high-end server, which enables in-memory processing, as well as the original Hadoop environment, enables you to work 100 times, up to 100 times faster than a conventional Hadoop setup, right? And also, the beautiful thing about Spark is, which started as a Scala platform, everything is written in Scala in Spark, but then it allows you to use these APIs. So you can use Spark SQL, which is nothing but SQL. You can use Spark Streaming for handling streaming data. Machine learning, you can use MLab library for GraphX, which will allow you to create tons of graphs, beautiful graphs. Spark R, which is nothing but when you want to code it in R. And then you have data frames, which is the beautiful thing, which is the latest thing, and it is the thing for data scientists. Why? So anybody understands what is a data frame before I just jump on it? Can anybody explain to me what is a data frame? I don't want to make it a one-way traffic, Anybody, just try. It's okay to be wrong. Yeah, please. Come again? Exactly. So data frame is a relational data. That's it. Basically, when you have a variable, which you can say a column, and when you have the entries, which are the rows of data. Right? So as data scientists, and literally 99% of analytics in the whole world is still being done on structured data, right? When you have some variable and it takes values, right? So that's the most important thing. People talk about so many things, so many big stuff, as if everything is going crazy. But no, it's a Facebook which can use a lot of pictures. Think about a company, let's say like Canadian Tires. Can it use pictures to do a lot of stuff? Maybe in the inventory management side, but can it use in terms of customers? Maybe, but that application will be very, very little compared to the list of managing tons of stuff when it comes to simply inventory management and supply chain management and so on and so forth. So relational data sets still hold the forte, right? It's not going to go away pretty soon, that's for sure. And so the data frame concept enables you to see it like a tabular data set, and it allows you to think in those lines, right? So that's a beautiful thing for data scientists, right? That doesn't mean that you can't do other stuff, but we will be focusing on this, which will enable us to do a lot of stuff. So now let's look at some of the attributes of Spark ecosystem. So now I have explained what is Spark, loosely speaking, and it has multiple API supports, which we talked: Python, SQL, Scala, Java, R. You can transition from any of these languages if you know, and then you can also integrate it with Spark's SQL, streaming, MLab, GraphX, and data frames, right? We have talked about it. Now, so if you think about a conventional Hadoop setup, every action, every operation is a map and reduce. Map is basically filter, sort, read and write data, and then reduce is nothing but aggregation, summarizing or coming up with something out of the data processing, right? And then ultimately it is written back. What Spark does is it allows something in the middle, and that something is huge because you don't necessarily, if you are doing data science application or something, you don't necessarily read data and just write it. Anybody can do that. You process a lot, you create tons of new variables, you do a lot of exploratory data analytics, you see it, then you think about it, and you do next step. It's not automated, otherwise everybody will be doing automated modeling. We don't, right? Very few things can be automated in that sense, right? So Spark allows you to do a lot of middle operations, right? And they can be arbitrary because they don't need to specifically follow a sequence, which Hadoop is very strict about, right? Second, it's an open source platform, so anybody can use it. You can scale it up yourself if you can manage it. It supports Java, Python, Scala, which are very predominant in the market. The beauty about Spark is RDD, the resilient data sets, right? Which essentially means that, you know, they have a fail-safe structure built in, so your processes will not fail. And at the same time, there is redundancy because of the Hadoop stack there, and also Spark has a beautiful thing about it called lazy algorithm. So it will not do something just because you typed a line. No. So for example, if I ask you to go from here to Brampton, it's not that you will just open the door and start running. Then you will ask, okay, how do you want me to go? You want me to take the train or the bus or car or what? You know, then I'll need to tell you, okay, take the train. Okay, then train from where? Go to Union Station and take that. But before I have told you all these steps, how to do that, and if you start to do it, it's idiotic, right? So that's the beauty of lazy evaluation. If you say, Spark learns that, okay, you have asked it to do A, B, C, D, E, but it will only process it when you will say it, when you will ask specifically to do it A, D, and E, then only it will process. So what it does is, had it been a Hadoop structure, right, it will do everything, irrespective, right? But Spark will learn it. That's called an acyclic something, you know. There have tons of nomenclatures here, but it just keeps it in memory. The moment you ask it to return an action, it does it, right? So that's why it is so efficient, and that's why so many companies are doing it, right? It doesn't just run, it runs efficiently, and it has a brain of its own, right? So that's more or less about what is it about and why is it about. And of course, you know, it goes without saying that you will use Spark only when you need parallelization of data. Otherwise, it doesn't make sense, right? You understand what is parallelization of data, right? Everybody or anybody wants me to spend some time over it? Open up. It's discussion. It's a discussion, right?
Yes, it would be nice if you could explain.
Okay. So imagine you have 10 billion records of data, and let's say you have 20,000 rows, 20,000 variables, right? Not just the rows, the columns are huge, right? Just storing that data is going to kill a lot of servers, right? And imagine if you just want to sort it, it will take maybe days, if not weeks, on a powerful machine, right? If you want to speed it up, you need multiple servers, right, working it together so that they can process it fast. But when we say parallelization of data, what we do is, instead of one huge server, let's say I have 100 desktop machines, just like a regular desktop machines, they are all connected together, and there is a master server or master machine which knows what data I am giving to which machine. Its job is to simply know what I have given to whom and what I should get back, what is expected to get back. That's the master, and then others are slave. Right? So it's simply that 1 billion or 10 billion records, let's say it splits into 10 million records, and then 10 million into whatever number of machines, it just gives it. Now, all these machines have got something which they can individually handle. That's very, very good way of doing it. So if I have, let's say, 10,000 pencils here lying on the table, and if you ask me, just sort it by color, let's say 3 different colors, it will take me weeks if I do that, if not whatever, right? But if I ask you, okay, hey, everybody, please come and please help me, everybody will do that, because everybody will know, okay, there are 3 colors and you just need to separate it out. That's the parallelization of data. When you split the job across different packages, across different hardware, but you remember what is being done and by what, by which machine, by which sector, and so on and so forth. That's a completely separate discussion in terms of how Hadoop does it, but that's loosely the concept, right? So that's the parallelization of data, and it only makes sense when you have lots of data. It doesn't make sense if you have very little bit of data, right? So that's the lazy and the RDD concept and the parallelization. Now there are two parts which are new in Spark, which are very interesting for data scientists. One is the data frame and second is the data set, right? So data frame, as these gentlemen told us, it's nothing but a tabular format of data. That's it. So software like Python and few others and R, they are all like, they don't do a tons of other stuff like, you know, whether they are doing the code checking even at the compilation stage or not. So they are geared towards handling data frames. Data set is another, it's, you know, it kind of enables real-time checking what you are typing also, you know, right at the compilation stage. So Java and Scala also, I guess, they are geared for that also. So, but for all practical purposes, for data science, we limit ourselves to data frames. Okay, so with the core, we have already talked about, these are some of the content, some of the libraries available with the Spark. One is SQL. No need to talk about SQL. If you don't know about SQL, you shouldn't be possibly talking about Spark for sure. Maybe I'm being offensive a bit, but that's ingredient, you know. If you don't know how to walk, you cannot possibly talk about how to drive a car. You know, that goes without saying, right? Then you have machine learning. For machine learning, you have so many snippets or so many algorithms being written, right? They are being written in R language, they are being written in Python, they are being written in Scala. And every time these algorithms more or less are same, but the way they work are different, right? So mlib library, let's say you are going in Python and you are invoking a library like mlib, then you use that functionality so that you don't have to write your own algorithm. You simply pass on your features or your variables, right, or your parameters, and use the built-in libraries to give you something out, right? So that's what mlib is. Similarly, GraphX is there, and you have many more. You know, it's endless. Now we know about Spark now, more or less we have some idea about it. How does it actually, how difficult it is to actually do it by hands, or how easy it is to do it by hands? When I started my journey in Spark, trust me, I wasted at least 2 months just to make sense of the environment variables of it. It's never stable. It's always doing crazy stuff which we can't understand, unless you are a IT guy who does it day in, day out, right? It's so tough. Why? Because everything is open source, so there's not a fixed documentation, there's not one way of doing the same thing, there can be tons of ways. So what I will suggest to begin with, you should always go to a pre-made cluster, if loosely speaking. So something which is available, let's say on AWS, it is available. You can just use a pay-as-you-go account on Azure, and you can just hire or rent a Hadoop, a Spark cluster, and you can type in your code. You don't need to worry about whether your path variable is set, whether you have these packages enabled or not, because if you get into that, you can also do it like the Cloudera way. You can have install your CDH and make it work. It never works the way you want. It's always tough. But one of the most beautiful things is, and this is what I think will be very useful for you, is if you can simply go to Databricks. It's a website, most of us will know about it, databricks.com, and there is a community edition for it. Just make a login, just make a username and blah blah blah, use the community edition. You can set up your own machine. For example, here you see this is my, I will just start from the beginning, let it be, otherwise we will run out of time, right? So here I have logged into my community edition. It shows that the default page is there. Now I need to tell, okay, what clusters I need, right? So I just go to the clusters, I create a cluster, let's say I just give it a name, let's say SP34, okay. And Python version 3, Python version 3 and above is the newer version. They are more stable, they support lots of other libraries, so always use Python 3. If you are still on 2.7 or before, please move, because those things are going to be redundant. And then simply create a cluster. It will take its time, but it will do it. So here what you are doing is, virtually, in a virtual environment, you are renting for free here, you are renting a Spark cluster, right, which has an inbuilt Hadoop layer, which has all the memory management, all the efficient packages and everything aligned and prefixed for you. If you have to do it yourself, it's a pain. Maybe Chandan will be able to help you on that. I certainly won't be, because I'm an econometrician, I'm an analytics guy. It's not my job to look into how do I connect these machines, where the cables are going and blah, blah, blah. Certainly not. Chandan excels in that. Maybe he can help. But for me, I'll simply rent it and I will use it. And a lot of organizations, big organizations, for example, they don't do this. They don't create their own clusters and then their own platforms, because it defeats the purpose, right? If you own everything, it means you have invested a lot of money. It means you have done a lot of capex, right? And that's a problem. The better thing will be if you simply hire or rent the capability from a provider, let's say like Cloudera, or let's say Hortonworks or Amazon, and so many small players also, and then just use it when you need, pay it when you are using it, otherwise don't pay, right? So it's the training which is more important. You should have the skills or the capacity to do that. Now we have our Spark cluster running, right? So let's go to our workspace, which is nothing but it will tell me, okay, what I'm going to use. So let me just show you some of the stuff that will make some sense to you. So for example, the easiest thing that you will think about is I have a data set, I want to just make sure that I am able to import it in my Spark environment, right? And then work on it. Challenge is Spark is obviously sitting over Hadoop, and then by design, generally these things are in Linux and all that. So now how do you switch your data set from a Windows environment, for example, and then load it to Hadoop environment and Spark environment? That goes into the data processing step. So which I can cover, but given the time I would skip it. Let's say I have already loaded it, saved it, just say copy and pasted it in my Hadoop environment. Now just to read it, because of this concept of data frames, it's so easy now that you can simply write spark.read.format, give it what format the data is, tell it the options. Okay, header, yes, there is a header. Infer schema is equal to true, means just read the fields, and then Spark will automatically assign whether it's a character variable, numerical variable, and so on, date variable, and so on and so forth, and tell where the files is physically located, right? Just do it. Notebook is now running, and that's it. Our internet connection is a bit slow. It should not take that much time, but yes, it's done. It's a small file. Assume it's millions and millions or maybe billions of records. Of course, it will take more time, and it depends on how many clusters you have rented, but it will never fail, right? Now we have read a file. Now we want to see how does it look, because that's human tendency, human nature. Everything is virtual, doesn't make sense for us. We need to have that physical window so that we can see. Very simple commands, nothing fancy about it. That the file that you have read, you have given it a name, sparkdf, and all that you want it to do is to show it. It just shows you the first 20 rows of data, and that's it. It neatly divides it with a boundary. Of course, it doesn't print it like let's say, how will you say, a table structure, but because it is Databricks. Had it been, let's say, an AWS, it will also support a Jupyter notebook. Have anybody has used a Jupyter notebook? It's used for Python. It's an IDE basically, essentially, right? So then you see it in even better format. Of course, you have to pay for it. So that's how you see the data. Let's do something fast. Let's say, okay, what is the count of the rows of the data? Quickly, I can see, okay, 41,188. Can I do some group by? Can I do some data aggregation, which is the key thing that once you have the data? Yes, very simple code. The file, then you ask it to group by on what? 2 variables. After grouping by, what do you want it to club? You want to do the count. Okay, you want to just see the number of rows, and then you want it to show something. That something is education, job, and count, and then you ask it to show, and this is what it does. Very simple, very intuitive, nothing fancy about it, because it's the way you are attacking it, right? Because otherwise, if you pick up a book on Spark or go on a tutorial on Spark, the first thing they will teach you is how RDDs and map and so many things that by the time you have studied it for 2 days, you have already lost your heart in Spark. You don't want to go on any forward. I have suffered. I know it very well. The first thing if I give you is how tough it is, you will never do that. You'll never be motivated enough. You don't want shit around everything, right? You want the things that you need. Not everybody is going to be a programmer, not everybody is going to land on the moon, no. But yes, everybody can drive a car. So please teach me how to drive a car, that's it. I don't want to fly a plane. That's exactly what my job is here, right? All that I'm telling you is how to drive a car, you know. If you ask me, how can I fly a fighter jet? No, that's not my problem, okay? So this is how you do it. Let's say SQL. Everybody is very happy about SQL because it kind of, you know, it's like, you know, my good old teenage days, you know. So everybody loves it. So I'm here, what I'm doing, I'm just giving it an instance. I'm giving SQL an instance within Spark, right? So that Spark data frame, the name Spark DF, I'm just registering it. That's just a command. Register table as OLS. I'm just giving it a name. So I named it. Fine, I have something, and now I can just run SQL as if I'm doing it in any other platform. SQL Server, within Python, within SAS, within R, wherever, within SPSS, whatever. What changes? Nothing. You only need to write spark.sql before the code, and then everything is SQL. Select star from blah, blah, blah. And then you ask it to show it, right? If you ask it to show it, it shows you. If you don't ask it to show it, let me run it. I don't know if I ran it or not. Yes, I ran it. And now you can also write it into another data frame. You want to do something, you want to write it back to a file, right, which you can use. You just assign it a name. I just gave it a name T. That's it. I didn't ask it to show it, right? It's done. What else? Let's say I have read a file and I want to see what each of these variables are. What are their names? What are their characteristics? You know, how many are float, how many are integer, how many are character, and so on and so forth. Here it is. It is called schema, right? This is what the schema is. You can change it, of course, if you want. But let's say we just go ahead with this. Okay, this is the schema. These are all my variables. Now let's do something beautiful. If whosoever has done any bit of work in Python, they will know what pandas is. Anybody who has worked in Python before? 3 people? 4, 5? Raise your hands. Why are you shy of me? Right? So 1, 2, 3, 4, 5, 5 or 6. Okay. So in Python, just like Spark, it's also an open source this thing, right? And a lot of packages or libraries have been created in C language, right? One of them is Pandas, right? Pandas has been designed to enable Python, for example, to work with data frames or tabular data, right? What you are doing is you are essentially going to Python from Spark, okay? So as if you are doing everything in Python, using Spider or Jupyter or whatever, right? So you are simply invoking, just like you would do in Python, import pandas, you gave it a name as PD, and now everything you are doing is as if you are doing Python. So you simply do, okay, data frame, do it, and give me a transpose, just let me see the data. This is what you did, okay? Now, blah, 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 let me quickly jump. I don't want to run out of time, otherwise Hiren will kill me, okay? So this is what I just create. I'm just doing some stuff. I'm just creating a list of numerical features from my data, and I'm just printing it just to check it, what it looks like. I'm just again importing it, even though it is not necessary. And I'm just trying to create, okay, a different thing, you know, scatter plot and something, which I will show it here. Now let me do some correlation plots. Simple. You know, some of these are like declarations. You want it in a color on blah, blah, blah. I've done some customization. You can do on your own. It's pretty simple, makes a lot of sense. Here, matplotlib is a library available in Python for creating graphs, 2-dimensional graphs and charts and bar charts and horizontal diagrams and whatnot, right? You have simply imported that in Spark, and then for every variable, what all numerical variables you have just created beautiful correlation plots. So that's your exploratory analysis that you do if you are a data scientist, right? You don't make machine learning models out of air, right? You use the data, you do a lot of analysis before you actually do something. And then you clean the data, you create new features. That's what we call as feature engineering. Once you have done your feature engineering, exhaustive feature engineering, then you do feature selection, which is again a tough job and a good job, and one of the most important jobs for data science. Once you have done your feature engineering as well as feature selection, this is a part of feature selection as well as feature engineering, I would say. And then once you have done it all, you have selected, then you have defined everything, then you design a pipeline, what we call, okay, we will do step A, B, C, D. And once you do that, then only you go to machine learning, right? Not before that. Otherwise, it's crap. Okay. So now I'll just jump. Now here I am, pretty. It will look like very tech stuff, but I'm doing simple things. I'm doing one hot encoding, which is a known thing in data science. If you will take some of our other classes, like I teach data science, machine learning models using Python. So it will make far more sense if you haven't done it before. So there we do hot encoding. Basically, let's say there is a category called jobs, and there are 15 different classes, right? So job can be student, can be a teacher, can be a doctor, can be an engineer, blah, blah, blah. So we create dummy variables for each of them so that we can manage it. That's hot encoding. Then you have, you do a lot of indexing so that you can keep the categorical variables separate and the numerical variables separate. And you do a lot of stages, you assign it separate stages, and you create a pipeline. That's what I'm doing. And once it is done, let's say now my pipeline is ready and I am going to create a logistic regression. Anybody knows what is the logistic regression? Anybody? You know it, right? So basically logistic regression is nothing but estimating the probability of something, probability of event, right? Which is different from probability, from estimating, let's say, a continuous variable. Let's say you want to predict, okay, given this much of my income, how much people will spend, right? Income and consumption, right? There are variables which can take any value. Somebody might have zero income, but their income can be in millions, right? But your consumption, it might be even zero, or it can also go to any value, right? But the problem happens when it is a probability. Probability is that whether you will default or not. So either you will default or you will not. There will be nothing in the middle, right? So either you are 1 or you are 0. So that a probabilistic or a dichotomous statement, as we say in econometrics, to handle that, you need a separate framework, which is, let's say, a logistic regression. Most of the machine learning applications are for dichotomous variables, right? Which take class options, right? 0, 1 or 0, 1, 2, 3, 4. You will go from here to there by using bus, TTC, go train, car, taxi, whatever. These are options. So that doesn't mean that a taxi is greater than TTC or whatever, right? You are not allowing it to, 5 minus 4 is equal to 1. No. All that it means, 5 is car, 4 is taxi, or 4 is train, or whatever, right? Now our pipeline is ready. It will take time, should run. Oh, I need to run C. I need to define it here. I didn't run that. And then we will jump. I'm jumping a few things, selected columns. Okay, I'll just go straight away, because otherwise to debug I'll take more time. See, debugging. Now let's say I'm doing all this, okay, I'm deciding my pipeline, I've designed my pipeline, I've given it some of the coefficients, okay, what is my training data set, what is my test data set, I have just split it 70-30. Normally if you have, let's say, 100,000 records of data, you want to make a model, you will do 70% data you will use for designing the model, and 30% of the data you will use for testing the model, whether you have done a good job or not, because just because you said it doesn't make sense, right? Then you run a logistic regression model. Here, for example, what I'm doing, I'm telling it that my feature columns are in the list features. My label is already given what these features are. What is my maximum number of iterations? For example, I've given it for 10 times, and then I'm fitting a model, right? After I do that and I ran everything, then I get a nice little ROC curve. Anybody knows what is an ROC curve and what is the usage in machine learning? Nobody? Okay. So what I mean is, when we design a model, it's not just we just code and go home. Anybody can do that. You can just copy paste, right? What is the difference between you and me? Let's say if I'm doing, and let's say you are a student, you are doing it. I have brought with me 15 years of experience. I know where it goes to shit. Right? So I will not make a model which looks beautiful but doesn't work. I will make a model which may not look very beautiful, but it will always work. Right? That's when this is the concept of called ROC curve, receiver operating curve. Right? What we do is we look at the false positive ratio and the false negative ratio. both the sides. So what I mean is, if let's say I made a model, but what that model is doing, it is telling that these 10,000 people are going to default, but actually out of those 10,000 people, only 1,000 defaulted. So 90% of the time, I am telling wrong people will default, right? That's my false positive. So had it been a credit card, let's say swiping, you are swiping and I have made a model, such crappy model, what will happen? Every time it will say, oh, this is going to be a fraud, it will block it. Once, twice, thrice you will leave, fourth time you will say, I am going to TD. This is going to happen, right? That's a cost of false positive, when you are causing inconvenience to customers. On the other hand, there is a false negative, that hey, somebody did fraud on my card and you didn't even stop it, because you thought it's not a fraud, right? So whenever you flagged, 90% of the time you are wrong. Or whenever the actual fraudsters, they were actually successfully able to commit the crime. They were able to transact. That's your false negative. You're wrongly saying something is going to default when it is not. So you want a model which is somewhere in the middle, where it's not flagging too many wrong incidences, but it is also not allowing too many actual frauds to go through, to filter out. That's the job of data scientist. Till now, whatever we have talked, even a data engineer could have done. But now you are going into a domain where it is data scientist, right? Then you also look, a lot of other things, precision and recall, which is again, mathematical jargons. But essentially, what you are trying to do is how often are you able to capture a fraud correctly, and how often you are actually saying that a good customer is actually good. That's kind of a precision and recall balance. Again, there will never be a model which is 100% on both the sides. You will always have to choose in the middle. That's when you need the training, you need the advice, and you need to hire somebody like me, right? So the next thing is, all these tools. And if somebody told you that they can make you a data scientist in half a day or in half an hour, they are shitting you. No way. Okay? You need to spend your time, because that's the only thing that you can do, and that's in your hands. But yes, spend the time correctly in the right direction. For that direction, we are there. Okay? Thank you.
Let's give another big round of applause to Shailendra. It was wonderful. They call him the rock star data scientist, and now we know why. And I learned a lot from that, so would love to continue with his courses. Just an interesting fact about AI, they do say research shows that over $15 trillion will be contributed to the global economy by 2030. So just an interesting fact. So it seems like the right time to really be, getting schooled and getting some education in AI. Our next guest speaker, I am very excited to introduce Pankaj Bakshi. He's co-founder and principal robotics process automation and artificial intelligence consulting at rpobotpro.com, and it's a robotics process automation and artificial intelligence consulting firm. So yes, take it away, Pankaj.
Thank you so much for the introduction. Hey guys, good afternoon. My session is not going to be as technical as his. I'm not a technical person. I'm an entrepreneur. I run a startup called RPA Bot Pro. This is a startup that works with RPA, AI, and Jira Consulting. So let's see if you guys can see us. 1 second, please. Okay. We have around 30 minutes left, so I'll quickly go through the slides. We won't go through the complete agenda. We'll talk a little bit about what RPA is, what your understanding is, if you have any questions on that. One of the tools that is the top tool in the market now is UiPath. We just got $500 million in Series D funding. We'll talk about that tool. We'll talk about how their architecture is set up. We'll talk about a RPA use case, and of course, my sales pitch, why us, RPA Bot Pro. So these are the things that we do as RPA Bot Pro. We are into consulting. We are into robotics as a service. We help you set up the center of excellence and Jira Consulting, which is more on the agile side, so I won't go into that today because today's our talk is only about robotics. I'll quickly go through RPA, what RPA really means. Like, I know most of the people currently who are in the technology field do understand that, but I'll take a couple minutes here. So RPA is the next generation tool. Why RPA instead of doing other IT transformations that most of the time that discussion comes up is RPA is something that works on UI. If you guys are familiar with any of the legacy applications and the pain that comes with it, transforming them to a Java-based or a web-based or a cloud-based application, two things. One, there is a big risk. You may lose a lot of data. There is a lot of compliance issues that come with that. And the other thing is you just don't have the skills. You don't want to invest that kind of money. I would say on average, transforming a old legacy application, something like insurance or banking field, can take you up to a couple of years. It can take you 30, 40 people. And that is where half of the people will leave the organization. You'll keep on hiring this 20 or 30 people every year, and the risk of losing the data or not being able to transfer. Now let's see what robotics is. RPA is robotic process automation. So what you're doing is you're leaving the legacy application as it is, and the same way as Pankaj or Hiren goes and looks at it, your bot looks at that node and says, okay, what does it say? Name, first name. And if I need to go into a spreadsheet and pull that data and input it there, your bot will do that. It will not make any changes to your legacy application or any application as such. So you're leaving the application by itself. You're just hiring a bot on the side, which is your electronic servant or your person to do it. So it can happen as an unattended bot, where it automatically does things for you, and attended, and we'll go more into that in a minute. Again, the second part of it was the value drivers. Why we do that? Because it's non-invasive. It doesn't go into your application, and the other thing is it only works on the UI side of it. So there is no interaction with your application till you tell the bot to do it. So if you want only your bot to go and input the names and the addresses and things like that on the screen, it will only do it. It will not go into the screen that's next to it where it says, say, run credit, write a policy, file a claim. So you are only making it do what you want it to do. Say you want Pankaj to do certain things, it will only do those things. What are the RPA tools currently in the market? We have UiPath, Blue Prism, Automation Anywhere, and WorkFusion. UiPath and Blue Prism are currently top of the market. A good thing for all of you guys, UiPath has a community edition which is free. Please go on their website, read about it. They even give you certification to become a business analyst, a solution architect, or a developer. I believe it is open till March 31st. So you have a small window, but it is not that difficult to become certified. You become certified, there is a lot of opportunities in the market or within your own organization. Currently, I would say within Canada, we'll probably have few hundred people who are certified on RPA. So that is a good thing for you guys if you want to come into this field. So I'm quickly we are running out of time, so I'll quickly go to the second screen. Okay. So the one thing is, 1 second here. Okay. So one thing that companies always ask, and if you go to the C-level executives or any of the program managers, is why won't I go with that? Why would I go with a new technology? What can it do for me that other transformation tools cannot do? Why do I touch something when I don't know about these things? And these are your enterprise level strategic objectives. So you want to say, hey, I want to achieve certain things. Why I don't do with the things that I already have? Why I touch a new tool? And the things that comes first to these kind of tools is because these tools are mostly going to be into your insurance, financial services, and your accounting sector. Because that's where most of the mundane tasks are, where people go and take that, okay, Pankaj, I sent you that report, go ahead and type that into this 20 fields, do that 400 times a day. But then again, that information that I'm typing could be someone's date of birth, their social security number, social insurance number, their driver's license, or things like that. So the very first thing that I want to make sure is that I do not want to bring a technology in there which is not compliant with that. The one thing that you guys must be familiar with is HIPAA, You go to Shoppers Drug Mart, they tell you, Pankaj, can you step back? There is a client standing there. You go to a doctor's office, you cannot hear other people's information because that's all health information that is all secured by law today. So these applications, the RP applications of today, like UiPath, are HIPAA compliant. So they do not take any of your information away from your environment and pass it along to other people. It's PCI, Payment Card Industry compliant. It is SOX compliant, that's Sarbanes-Oxley. If any one of you guys are from the accounting side, you would know about it, that you cannot move funds between different parts of the organization. So if you have someone say, I bought a life insurance and I gave that money to the company, it should be trackable. You cannot take that and say, okay, we are going to buy 50 limousines for our executives. So things like that, so that where the thing is. Why are we looking at RPA? We are looking at saving the revenue. So when you're looking at the cost reduction part of it, the FTE to a bot analysis is not one-to-one. So if you're taking an FTE's work, so if Pankaj does 300 or 400 transactions a day, and it takes me, say, 3 minutes to do something, a bot can do the same transaction less than a second or a fraction of a second and have no issues with that. So what that means is that work stays within the environment, your organization keeps it, and now you can put those FTEs elsewhere. And the reason I'm saying put those FTEs elsewhere, because that question comes at multiple points. People always use the phrase in RPA, we are going to get rid of FTEs. As soon as you say that and you're going into an operations market, the operations manager or the director is going to say, I don't want to get rid of my people. I've been working with them for 25 years. We don't want this technology in our environment. If you're going to let me keep my people and save their job and make it easier or make it faster or make it more productive, I'm good with that. Otherwise, we're not discussing. I'll throw some wrench in there and you're out of it. But if you say that if I'm going to take this FTE who has been there for 20 years and has excellent skills, he can stay there within the organization but do some other work, but take this bot as his work. So what you're going to do is out of these 10 FTEs, you moved 8 into other roles. That could be client-facing, sales, anything, or analysis, or BAs. But these 2 FTEs stay there, and we let this bots take care of these 8 people. So that's where the organizations are moving now. So a year back, everyone was saying we are going to get rid of FTEs. Today, the discussion is we are going to reuse FTEs elsewhere. You also open new markets because you have more data now. You can run better reports on that data. You know what to do with that. The low implementation cost, that attracts your organizations, and the fast ROI. On a transformation project that I worked for, I don't know how many of you guys come from the insurance, but there's a very common application called Guidewire. The organization that I was working with, they said, we won't invest in Guidewire, we'll invest in a technology called XYZ, because we want to develop that as a competition to Guidewire and then go and sell it to other people. I started there in August 2014 in that organization. I left in December 2017. It was still not done. If we had RPA, and how many policies we were going to transform? 7,500 policies. So instead of keeping that 7,500 policies on that application that they were going to transform, had they put RPA on that and all the application, if they wanted to automate, if you had good developers, I would say on average you'll take no more than 6 weeks from inception to finishing it, if you have really good developers and BAs. Took 2.5, 3 years and they were still not done. And I have just heard that they did it like 6 months back now. So that's your fast ROI. Instead of waiting 3.5 years or 3 years to transform, you're doing it into weeks or months. Value, you reposition your client. So I won't go through all these things. What I want to get to is the implementation. So what kind of bots are there in the market? What can I do with that? There are client-facing bots, which are chatbots. I'll give you an example of chatbot. So say you go to a bank, or you call CIBC, or you call RBC, and you say, hey, I'm your high net worth client. I have $200,000 sitting here. I wanted to see if you can do an FX trade, a foreign exchange trade, and tell me how much it's going to be in US dollars. So there is a big FX trader floor for a CIBC here in Toronto, with around 100 people sitting there. On average, I would say not average, on the lower end, their pay would be 100K. So they're 100K plus, and all they are call center agents, whether certified All they do is Pankaj calls them and good morning, Pankaj, how can I help you? This is my account number, this is my social security number, or whatever validation they need. Once I give them all that information, what do you want me to do? Can you tell me how much that trade is going to be in US dollar or in euro or in yen or anything? And they give me the number, and when I say, yes, I'm good, what account would you like us to transfer? This, and that's it. And that's all they are doing. So one of the projects that I did was with IBM Watson and Blue Prism tool, where a chatbot window would open on the client. So client goes in there and he logs in. So there are two things to it. There is an API to IBM Watson, and then there is the Blue Prism tool. So you're going in there and you're saying, I'm looking for this trade, and this is who I am. And once you log in with your credential, it brings up that screen, and now it looks at up your profile and says, okay, what is your name, all that validation, the good part. And once that is done, it goes and the Blue Prism runs the code for you. It runs a code, it tells you, hey, this is how much money is available to you to transfer if you want to do it in a yen or this and that. And once you say, okay, good, go ahead and do it. So IBM Watson again goes and runs that schedule and changes that money, and then it gives you the validation of it. So now you see that your $100,000 employee, all he was doing was the same thing. And now you can have hundreds of clients who are waiting on the phone saying, your wait is 25 minutes to get to the line. They are immediately doing the transactions. The more transactions the bank do, the more money they make. That is your chatbot. Simple integration with IBM Watson, FX Trader of the bank, and your Blue Prism. You guys can also see this video. It is available, something very similar to it is available online under Busy Ping, and I can post that link to you guys. These chatbots can also be internal. Now this was an external. Internally, you're talking to your IT and saying, hey, I am this guy and I need my table space to be extended, or my ID got logged. And all these people are doing is sitting there taking these simple instructions from people and going, okay, your ID got logged? Oh yeah, there you go, unlocked. Or you need extra space on your table? Here you go, extra space. So you can have an internal chatbot which can do that for you, which will integrate with Blue Prism with your database. And once you give the people the authority or the log and say, at a manager, you can have 2 gig of data on your Outlook. As a senior manager, is 3 gig. But as a senior manager, if you had certain things, you can ask for extension. So this thing can send an email to your manager. The manager says, accepted. It comes back. It opens up that chatbot. It says, okay, IBM Watson, go ahead and extend the space to you and send it back to you. Let's see if it was not there. You will give that information to Hiren. Hiren will take it to the manager, wait for his email to come. Once the email comes, reads it, extends the table, calls back Pankaj, and guess what? By that time, Pankaj doesn't need that, or the email that he was trying to download is gone. So all these things can be automated. So these are chatbots. In the middle office, you're looking at HR, finance, claims, policy admin, and LMS or learning management system. As part of the PMO lead for Capgemini, part of my job was making sure people do their courses. You don't do your courses, we are responsible to RBC. RBC comes and it shuts us down and says, okay, Pankaj, Hiren, Chandan, you guys can work. You don't have your LMS done. And all I was doing every day was looking at that sheet and sending an email, hey guys, please complete your courses. If I had a bot there, which would go every day and read and say, okay, so today I am at 98 people had completed, 5 people are still left, and I need to send that escalation to them. So if they don't, as the numbers drop, the days drop, there should be an escalation going to their manager or whoever that is. My bot will do that for me. So I won't have to go and follow up. The only time I would see is I will see a report at the end of the day at 5 before I'm leaving. Pankaj, 99% completion of your courses. So that's one thing. Claims. You are working in claims environment in a bank or an insurance company. On average, you'll see 8 to 10 legacy applications, and I'll tell you why there are so many applications for one claim. An insurance company doesn't grow organically. So insurance company goes and says, hey, Mr. Little Company, how much policies do you have? And they say, we are at $4 million. Okay, I'll give you 4.1. You want to sell the business to me? And go and write more business. They go to another one. So same thing that happened with RBC and Aviva. RBC sold their auto insurance to Aviva. So Aviva is never going to integrate that in your system again to the back point that we started, the legacy application, the risk of it. And why would I put a more expense on it? Let it be there. I have these claim adjusters who can go and run that. So what happens, Pankaj calls and says, hey, I got into, say it's a disability insurance. Hey, I fell and I want to file a claim. The first thing that RBC claim adjuster is going to do is see how much coverage do you have. And if it was one application, very nice, life is easy. But guess what? There are 6 different applications within that. So one place I sold you this part, the other agent sold you something, and now I want to see within those 6 applications, how much coverage do you have? Or you have or you don't have. But I need to go into all 6. So while that claim adjuster is talking to me, he'll say, okay, can you give me your last name and first name? And he goes into a attended bot. And I'll come to attended and attended in a minute. In the attended bot, he goes there and say, go fetch. It's like a little machine that goes there and it searches whatever you ask it to do, but it's already scripted. So it goes into all the 6 applications, it logs into with your credentials, it pulls that data and it puts in front of you in a little spreadsheet and say, yes, Pankaj has 1,000 here, 5,000 here, a $500 application here, or this. So his coverage is $9,000, and this is how much he should be getting paid for. And guess what, if it was not there, this person will be spending 30 minutes logging and reading that and putting it in a calculator and doing that. So these are the kind of things that a claims person can do in finance, which is the big thing currently. You have OCR tools. UiPath has Abby. There are other tools like Kofax. There is a PDF reader. The PDF Adobe provides you. So what you do is you take your invoice like this, you just scan it. Either you scan it, it comes through an email, whatever ways it reads the account number, it reads the data, it populates it into your QuickBooks or Intuit or any system that you have, and it generates the payment for it and says, yes, qualified under $500, we can send the checks in. So this is one of the biggest use cases that is there. So I'll take a couple minute break, and if you guys have any questions up to here. Is it making any sense, or I'm talking too fast? Yes, sir. Looking at back office, you're looking at PMO reporting. You are in IT, you are tired of sending that report every day on Friday, that program manager or the PMO lead is writing you a really nasty email, I have to go home, you guys don't send the report, and then he takes that 20 reports or 30 reports and consolidates and sends it to program manager. That can be automated through a bot. So that could be an a unattended bot. So what is the attended and unattended? Attended is when you go and you trigger it and say, go work. Unattended is which reads something either by time or some of the trigger or some other API triggers it off and says, hey, go do something. So say you have a unattended bot where all these reports come from all over the world, and I am an SVP of RBC or Scotia Bank, and I want to see this report at my desk at 5:15 or 5:30 every day to see where my bank stands. So someone has to consolidate that, put it in a deck, create a dashboard, and present to him. Instead of doing that, if all these reports come through email or they are dropped into a shared folder or into a cloud location, your bot can ask, once they're all there, it can read it, it can consolidate, consume, create the dashboard, and send it through back to email, put it in a folder, or put it on a cloud location. IT services, this is where majority of the bots, yeah.
Can it work in a real-time application like fraud detection? Credit card
Yes.
transaction happen?
Yes. Yeah. So AML. So AML and AML, ADF, or anything. So you're putting triggers on it, and you're saying that, hey, once this trigger comes, don't just keep on parking that. If it goes above 10,000 on these certain accounts, I'm just taking a small number, put this report and send it to me right away. So what is happening is at your desk, what you are doing, at the end of the day, you are running the report again and again and say, every day I'll run the report and then I'll catch it. Here it is saying, if I go above this meter, say 10,000 20 transactions in a day above that, immediately trigger that, it will do that. So any kind of reporting that you want to do, it will happen at. Okay. So there are other things like resource management, where resource management is your onboarding and offboarding, and there is a big issue with that on the InfoSec side, that people come in, you hire a claim adjuster, he has to have access to 10 applications, you only gave him 8, now what? The person can't work. He's just sitting there saying, I don't have access to other 2, and you're paying top dollars for that. So it's an onboarding of it. So this thing, once you say, Pankaj is a claim adjuster level 3. So whatever privileges that come, and if you guys are familiar with Oracle applications and all that, so all you're doing is creating a role. So it takes that role, takes all the privileges, and it goes and it gives access to all of it. You said Pankaj left. It goes back and it withdraws all of it by itself. So no one has to physically go there and say, undo, 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 or give, give. And then what happens is, I have seen on occasionally people would leave and they still have access to SharePoint on cloud. They went, there was an ID for Scotia Bank main, and there was a separate ID created for that. The guy went home, now he has access to everything. No one knows, because no one's tracking it. So if there was a bot that whose only job was to make sure when Pankaj comes in, give him all the access, and when Pankaj goes, make sure everything is gone, that ID would have been disabled. So that's your resource management. We'll talk a little bit about the UiPath architecture, platform architecture. Please don't ask me any technical questions. Okay, so there are three things within a bot, a platform. One, how do I create this bot? The other thing is, how do I run this bot? And the very basic, what is a bot? So when you talk about Studio here, this thing here, what Studio is called objects and processes. That's the two things within that. What is an object? Object is, hey, how do I automate Microsoft Excel? How do I automate a Oracle application? So all the fields within that, how do I automate? How do I track them? That is called an object. So you are not blindly go and say, hey, I'm going to automate anything. First, you need to know what I'm going to automate. So if I'm going to automate, say, a guide wire, I need to make sure that all the fields of it, my system understands. What is that? That creation, that box is called object. So you created that. The next thing you do is write a process. What do you want within that to do? I want you to go and create a user, create a policy for him, give him a policy number, and send an email. So that is your process. So that's two parts of it. What is an orchestrator? When you have multiple bots that are running. So you, as a unattended bot, you may have one or two, but if you're a big organization and you have 300, 400, 1,000 bots running, attended or unattended, you run through orchestrator, and that is where it gives you all the reporting. It tells you how many applications it ran, how many, not applications mean the IT application, how many processes it ran, how much time it took, did anything fail? That's under exceptions. Did it pass all of it? Where did all that information go? What time it ran? All this can be done through orchestrator, and again, the very small, the very basic thing is your bot, which can be attended and unattended. We just discussed that. And to the technical people, what is it compatible with? Citrix, Desktop, SAP, Oracle, any of these new applications. And a lot of these are coming up as packages. UiPath comes with Abby. It's an OCR tool, which is very, very much in demand in market right now. We discussed that, so I won't go with what UiPath key definitions are. So let's talk about deployment options. People who are on the infrastructure side or even on the executive side, they want to see, hey, where are you going to put this? How do I implement it? I'm very interested in it, but how do I implement? So there are different things that you want to do. There is called high availability, which is simple as on-premises, on-prem, and I want to make sure it is under my control. I want to make sure it runs 100% of the time. I don't want to risk anything. So that's high availability. Web server or on a single machine. On a web server, you can have it for multiple clients, or you can have a single machine. If you have an attended bot where you just say, hey, Pankaj is our main claim adjuster. We want him to have the ability to do all these things. So we'll give you one bot, Pankaj. Or there are 10 of these people. We'll just give you 10 bots on your machine. And we don't want any headache. We don't want anything more than that. So that's on a machine or on a server within a small environment like SimCore or Capgemini. They have their service centers here. There are 200, 300 policy admin people sitting, payment admin people sitting, and you set it up within that environment, and everyone can go and run the bot as required. You can deploy it in the cloud. This is what our expertise come in. And why do you want it in the cloud is one, that you want that headache away from yourself. I don't care about the infrastructure. I don't want to worry about the space. All I want is the work should be done. It should be done on demand, and whatever I use, I only want to pay for that. So I don't want you to come and say, hey, because of your organization, this is going to cost you $2 million in server, because this is how much work you guys do. This is how much space I'm going to need. Go to Amazon. Pay as you go. You use X number of data, you pay that amount. You multiply it by 100, you pay by 100 times. So you're not worried about it. The other thing is, there are organizations which are small. Your insurance brokerages. So the insurance brokerages that you see within GTA, you always see 5 or 10, 20 people sitting there, but they are all part of a big organization. That big organization is a group of, it could be an MGA, Master General Agent or anything, and they have 25 or 30 offices. So what you want to do is you want to give it the access to them and say, hey, any one of you guys want to use this application, our bot, it is available on the cloud, go use it, and you pay as you go. So that's the other option. And the third thing that is very important and should be very important to anyone, irrespective of bot, is your disaster recovery. For disaster recovery, you want to make sure, hey, if this bot goes down in cloud, this bot goes down on server, on a machine, anywhere, what is my backup plan? Is there other bot that is available to me, or do I need to run and say, hey, we need to hire Pankaj back and say, hey, Pankaj, can you work on that? That is called DR. So what you do is either on your on premises or in cloud, you can have the DR disaster recovery or the backups, DR centers done, and you can have an active data center or an active passive. So active is when you have both of them. So it's copying over whatever you're doing here is copying over, and active passive is one is active, one is passive. So it flips between that. So we won't go into that detail because it's not that relevant here for now. 5 minutes? Okay. Okay. So all that done. You guys are all my executives. You bought into the idea and you say, okay, Pankaj, go ahead, bring it on. Let's see what you can do for you. Do a POC. And now it's time for me to come and prove this can work. So this is a document ingestion and indexing. This is a very common thing that works at different places. It works in claims, works in policy admin, works in accounting, works in doctor's offices. So what happens is you send someone a document and all he needs to do is read that and say, oh, okay, so this is a claims document, goes to Hiren. Okay, this is a policy admin document, the client is sending something, goes to Chandan, or it goes to you, or something like that, or it's a doctor's report that I need to add to someone. And what happens is in today's world is people are scanning, it comes on their screen, and there are tools like Case 360 workflow where you highlight and you say, okay, this is a policy admin document, attach it, put it in this row and let it go through. So what was happening within this organization, and this is a real use case, I can't give you the name, but this is a bank's insurance company, and an outsider business process outsourcing company within GTA, which was handling that. So the challenge was that for each document, it was taking around 8 minutes from end to end for someone to pick that up, scan, send it through, index, put it in the second. So there are two levels of indexing. One is where you say, okay, claim, everything in. Okay, then the person goes, okay, claim, what is the policy number? Oh, who's the client? Oh, okay, so the policy number, the client within this household are 4. There is a Pankaj Bakshi, there is Anu Bakshi, there is another Bakshi in the household. Or we need to split it up. Or there is a payment which came for a $100 check came, but the client has 3 policies saying, put $60 to this policy, 22 here and 22 here. So that was taking an average of 8 minutes. Human error ratio, someone is copying and pasted in wrong document, put it elsewhere. There is no control. A human is a human. 5%. Average delay on SLA. There is a commitment between the business process outsourcing to the bank, and it was on average 6% it was delayed. In banks, when you have committed, that can impact you a lot. It's in millions in a year. And the other thing was the client wants to maintain legacy applications and said, no, I'm not going to get rid of my legacy application. Work with it, deal with it. I want everything like I gave it to you, but I want 100% clarity on that. And all these 5%, 6% should go away. The 8% should become even smaller, 8 minutes. And what other thing was the quick win was required because you want to make your bank or your insurance company happy, so you get more business from them. So what was done, we cannot go into the details of how that bot was developed, but there was a bot that was developed, So how long did it take? Solution development time was 7 weeks. Initiate and plan was 1. Discover and define was 2. Now discover and define is your understanding the process, documenting, and if you guys go through UiPath, it has a specific document called PDD, process definition document, which is nothing more than a PRD geared towards RPA, and then you go the solution documents and all that, and that was 2 weeks. Design and develop. Design and develop was when that PDD or STD, that the solution document went to our developers and they did an iterative plan. It took them 2 weeks. Deploy and improve was the UAT and the hypercare. So a total of 7 weeks were into that. So what tool was used? RPA. It was a cloud deployment. DR was 2 data center, and the return on that was 84% reduction in OPEX costs with 2 indexers required to handle work, exceptions handling only, and I'll come to the word exception. This is very important in RPA world. Document ingestion times reduced from 8 minutes each document to less than 5 seconds. Because as you guys, we walked through this process, you can understand that now the bot is doing it and it's not reading it and thinking about it and then copying it. It immediately goes, and I'll see if we have few minutes, I can show you a demo as well. And human error reduced to 0.5%. Because there is no human really required in there. The human error now is whoever is sending those documents from the back, so they are taking this document, someone has to open all these envelopes. So when they're opening the envelopes, either they're putting the paper upside down or this way, now your bot cannot read it. It has to come this way, it has to be upside. So they think, and company is maintaining an SLA of 99.5%, and these are the things which are like related to other. So I want to quickly go back to the exception handling. Exception handling is what your bot cannot handle. And what your bot cannot handle is that things which are, say, here you had the claim number here, and all the standard documents come like that, but suddenly someone changed it and he wrote the claim number here. Or instead of typing something, the document that come from doctors which are typed, someone hand wrote something. So these are exceptions. So the system will throw these out and say, okay, I cannot handle that, and it will be parked. These are called exceptions, and you need a human or someone to come back. So either you can have a bot go and redo that. I want to go into that much detail, or you can have someone manually do it. I won't go into that. We are already over that, who we are, like what services we provide. This is my team. Anu is the founder. I'm the co-founder. And my daughter, she runs Jira Consulting. And that's it, guys.
Okay.
Any questions?
We are having our Crypto Bay meetup, so every Tuesday here, usually 7 to 9, but today for our dear friends Hiren and Chandran, the cryptos, we're very excited that you were here. They're going to be starting around 8 o'clock, so we would absolutely love for you to stay and be a part of that. There'll be more pizza, refreshments, and some very interesting synergies between AI and cryptos. So we do hope you'll stay, and thank you again for being here, and thank you to all our speakers, and of course, Hiren and Chandran. Thank you.